Hello everyone, welcome back to our channel. Today we are really excited to share a project that we have worked on, skin disease classification using AI. Now let's begin with the problem we are trying to solve. Skin disease affects millions of people everywhere, but here is the issue. In many places, especially rural areas, there simply are not enough dermatologists. People have to travel for wait long periods or sometimes avoid treatment completely. So we asked a simple question: can we build a system that uses AI to detect skin disease instantly and accurately? If yes, it could help people to get early awareness and seek treatment faster. To train our model, we used a high-quality dataset from Mendeley data with 9,548 dermatology images across 5 diseases: acne, hyperpigmentation, nail psoriasis, SJS10, and vitiligo. One challenge we noticed right away was class imbalance. For example, SJS10 had the highest number of samples while hyperpigmentation had the least. This imbalance affects how a model learns, so we had to handle it carefully in later stages.
Thank you, Fahima. Now let's dive into how we actually build the model. For our architecture, we used efficient NAND P0, which is a powerful but lightweight deep learning model. At first, we tried using it as a frozen feature extractor, but that only gave us around 35% accuracy, clearly not enough. So we fine-tuned the upper layers of the network, added a deeper classification head, and used dropout and batch normalization. This allowed the model to learn more specific features from the skin images. On the right, you can see our training history, both the accuracy and loss curves. Shows smooth and stable convergence. Using a warm-up learning rate followed by exponential decay helped the model learn gradually without overfitting. By the end, the validation accuracy reaches 94.97%, which is confirmed that our training strategy was effective. Now let's talk about our project key result. Our final model achieved a strong result. We reached 94% test accuracy, which is a huge improvement from our baseline. This shows that fine-tuning the model and applying class-weighted training really helped the system understand subtle differences between the 5 skin diseases. Let's dive into performance metrics. When we look deeper at the performance metrics, the results were very encouraging. All 5 disease classes achieved over 92% F1 score, meaning the model performs constantly well across the dataset. The confusion matrix also shows a strong diagonal pattern, indicating the model's predictions align very closely with the true levels. Overall, these metrics tell us that the model is accurate, reliable, and well-balanced across all classes.
Thank you. Now let's look at how we made our model accessible to real users. We built a Flask-based web application that allows anyone to upload a skin image and instantly get a prediction. Here's a quick demo. The user simply drags or select an image. Our app pre-processes it and sends it through the model, which generates a prediction in 2 or 3 seconds. The app then displays the predicted disease confidence score for all 5 classes and basic medical recommendation. This makes our system practical, user-friendly, and ready for real-world testing. In conclusion, our project successfully demonstrated how deep learning can support early skin disease detection using transfer learning, fine-tuning, augmentation, and class-weight balancing. We built a model that achieved 94% accuracy and performs consistently across all classes.